This is a Burchill, your Green Book 9B question number 2. We've got a mass hanging by 2 strings, and it's 60 degrees angle of each of those strings between from the vertical. Tension force in each, that's the capital T, and the 3 kgs for the mass. We're asked to first find the force due to gravity, which is mass times gravity, so 3 kilograms times by gravity 10, and we looked into all the units, meters per second squared versus newtons per kilogram, and why that is. Main thing is we're dealing with a static, that is a not accelerating object here, so we're looking at newtons per kilogram to find the force that mass applies. Moving on, question B, we've got the vector addition to show that there is a zero resultant force on the mass. So we have to add up all of the forces. We've got them numbered in orange here, 1, 2 and 3, and in the order that we've added them. On the right hand side here we've got a free body force diagram showing the forces acting on the dot in the centre. The dot in the centre represents the mass, and we've started with the 1, T1 if you like, and then T2 top to tail. This is the circled orange part on the left. So T1, then T2, then FG, and it goes back to the start showing that there is a zero resultant force. A few other little bits and pieces in there that help you work out certain things. And C, starting from the vector addition there, we know from the interior angles of a triangle that they add to 180 degrees. That means all of the internal angles are 60 degrees. That means this is an equilateral triangle with T and FG being the same, 30 newtons. That's one way to find it. That's our method 1. And method 2 is, on the left hand side here, is splitting that main initial green triangle into 2 parts. That gives us 2 right angled triangles, and we can find, that means the whole of FG vector is split in 2. So we have to find the right hand edge of the purple triangle. That's the edge that's opposite to the 30 degrees, which would be half of that angle that's been split from the green triangle. And performing the calculations, looking at what you've got there, it'll give you 15 newtons for that section, and since it's twice that length you get 30 newtons, which means it matches with method number 1.